Out in the vast Pacific Ocean, where the horizon melts into steel blue water, mighty schools of tuna skim the waves at incredible speeds. Built like living torpedoes, they travel thousands of miles relentlessly, chasing warm ocean currents and shoals of smaller fish. Yet somehow, these wild ocean predators end up as a neat box in an American pantry or a succulent fillet on a seafood counter. Most of us only see that final shape, a label, a price tag, maybe a quick tuna salad or a weeknight pasta dish. But between the vast ocean and your dinner table lies one of the most ferocious modern food supply chains. Industrial fishing vessels track tuna migrations across ocean basins, using cutting-edge technology to find them. The moment a fish is brought aboard, a new race begins, the race to preserve its freshness before nature begins to destroy it. From there, the journey becomes colder and more tightly controlled. Tuna is transported from cold holds at sea into powerful freezing systems, then to high-tech processing plants where cranes, conveyor belts, and diamond-coated saws take over. Step by step, the agile predator is now transformed into fillets, loins, and cans, designed to stay safe and flavorful for months, even years, on store shelves. In this video, we slow down that invisible journey. We follow the tuna as it is pulled onto a train, through the cold chain that protects its quality, and inside the state-of-the-art factories that process tuna for American households. Eventually, you may never see a simple can of tuna on store shelves the same way again. Do you think large-scale industrial fishing is a necessary part of feeding the world? Or should the future of tuna be based more on small-scale traditional fisheries? Comment 1 if you believe in an industrial future, or 0 if you believe tradition should lead the way. And if you want to continue exploring how everyday food actually gets to your plate, don't forget to subscribe so you can follow the rest of this journey with us. Tuna are not ordinary fish. They are some of the strongest, fastest travelers in the ocean. Sleek, muscular, and built like natural torpedoes, many species can reach speeds close to 45 miles per hour, letting them slice through the water with almost no drag. Their warm-blooded muscles give them unusual stamina, allowing them to swim day and night without slowing down. Every year, tuna begin incredible migrations that cover thousands of miles. Yellowfin, big eye, and skipjack follow warm currents across the Pacific using underwater highways like the Kuroshio and equatorial currents. A single tuna can cross more than 10,000 miles in its lifetime, passing from the western Pacific to the American coastline on journeys driven by temperature, food sources, and instinct. To survive such long-distance travel, tuna rely on unique biology. Their hearts beat faster than most fish, pumping warm blood that helps them dive into colder depths where prey often hides. Their vision is extremely sharp, allowing them to spot shimmering schools of sardines or squid, even in dim, deep water. These migrations also shape how the global tuna industry works. When tuna gather in large schools along their feeding routes, fishing fleets know exactly when and where to look. Modern vessels use sonar, satellite data, and even aircraft to track these patterns, turning natural migration routes into predictable windows for harvesting. Before we look at how technology and fishing gear intercept these fast-moving giants, it's important to understand this part of their story. Tuna are valuable not just because they taste good, but because they're built for speed, endurance, and long journeys across oceans. Their movement is the foundation for every step that follows, from industrial fishing to cold chain preservation and factory processing. As tuna travel along their long migration routes, industrial fishing fleets position themselves with one goal: meet these powerful fish exactly where they gather. Modern tuna harvesting is nothing like the small boat operations of the past. Today, it's a coordinated system built on sonar, satellite readings, and machines strong enough to handle hundreds of tons of catch at once. The main tool behind this scale is the purse seine net. This giant wall of mesh can stretch close to a mile across the water. When sonar or spotter aircraft locate a school, skiff boats race out to circle the fish, laying the net in a wide ring. A steel cable then tightens the bottom, turning the net into a closed pocket. In just one set, a vessel can haul in 100 to 200 tons of tuna, enough to supply a factory for days. Once the net closes, the deck becomes a blur of movement. Hydraulic cranes lift the heavy catch, and conveyors pull the blue-silver fish on board. Crews work quickly because every minute matters. The sooner tuna reach the chilled storage holds, the better their quality will be when they reach American markets. For premium species like yellowfin and bigeye, fleets often choose longline fishing instead. Miles of line trail silently behind the vessel, each hook carrying bait spaced far apart. Long lines catch fewer fish, but the condition of each tuna is far superior: cleaner flesh, minimal bruising, and perfect texture for sushi and sashimi buyers who demand excellence. Technology in the wheelhouse guides every decision. Sonar screens show underwater shapes in real time. Satellite data marks temperature shifts that attract tuna. Some fleets use drones or helicopters to watch for diving seabirds, one of the simplest and most reliable signs that a school is feeding below the surface. With these tools combined, the open ocean becomes a workplace that can be mapped and predicted with surprising accuracy. Even with all this equipment, tuna fishing is still demanding and unpredictable. Weather can shift suddenly, nets can tear, and a missed school may cost thousands of dollars in fuel and time. Every successful haul reflects teamwork, timing, and experience earned over years at sea. With the catch secured, the next challenge begins instantly: preserving freshness before heat and time start to break it down. And that cold chain race is exactly where our journey continues. Once tuna are hauled onto the deck, crews face a challenge just as important as the catch itself: stopping time. From this moment forward, every degree of temperature matters. Without fast chilling, tuna flesh can lose color, soften, and drop in value within hours. That's why the cold chain doesn't start at the factory, it begins right on the boat, minutes after each fish leaves the water. The first step is the slurry ice tank, a mix of seawater and finely crushed ice that creates a super cold bath. Crew members slide each tuna into the swirling mixture, bringing the core temperature down quickly and evenly. This rapid chill keeps the meat firm and preserves the deep red color prized in U.S. and Japanese markets. For high-value species like bluefin or large yellowfin, some vessels go even further. They use blast freezers capable of reaching 60 degrees Fahrenheit, a temperature so low it stops enzyme activity almost instantly. Tuna frozen this way can maintain sashimi-grade quality for months, even after traveling thousands of miles to distant ports. Below deck, the ship's RSW, refrigerated seawater system, keeps the catch cold as the voyage continues. Giant insulated tanks circulate chilled brine around the tuna, maintaining a steady temperature throughout the hold. Fortune. When the storage holds are full, the process expands beyond a single boat. Reefer vessels, essentially floating refrigerated warehouses, rendezvous with fishing boats at sea. They transfer tons of frozen tuna into massive sub-zero chambers and carry them across entire ocean basins. These ships maintain exact temperatures from the moment the fish leaves the water until it reaches port, sometimes thousands of miles away. By the time the tuna arrives on shore, it is nearly as fresh as the moment it was caught. Every step ice baths, blast freezing, refrigerated brine, and mid-ocean transfers exists for one reason: to lock in quality before the fish ever sees a processing plant. With freshness secured, the next phase of the journey moves on to land, where enormous machines and skilled workers transform frozen giants into fillets, loins, and cans ready for American homes. And that is where our story heads next. Once the tuna reaches land, the work shifts from the open sea to a controlled, highly organized processing plant. The goal here is simple: turn frozen fish into safe, consistent products for American consumers while preserving as much quality as possible. Every step happens at low temperatures to keep the meat firm and prevent color changes. Large tuna, weighing hundreds of pounds, are unloaded with cranes and placed on conveyor belts that carry them through the chilled facility. Workers wearing insulated gear guide the fish toward diamond-coated saws designed to cut through frozen flesh cleanly. Processing the tuna while it is rock-hard helps maintain structure and keeps the deep red color that buyers expect. After the initial splitting, tuna enters one of two main paths. Premium species like yellowfin and bigeye move to the filleting lines. Here, trained workers shape loins and trim away imperfections. These cuts must meet strict standards because many are destined for sushi counters and restaurants, where appearance and texture matter as much as flavor. Smaller tuna, especially skipjack, head toward the canning line. First, the fish is cooked in large steam ovens to soften the meat. Once cooled slightly, teams of workers remove skin, bones, and dark sections by hand. Even with modern machinery, this step still relies on human attention to keep every can consistent. Clean, trimmed meat then goes into fast-moving filling machines that portion it into cans with brine, oil, or simple seasonings. Mechanical seamers close each can with airtight precision, preparing them for sterilization. In pressurized chambers heated to about 250 degrees Fahrenheit, the cans are fully cooked and made shelf-stable for months or even years. After cooling, the cans pass through multiple quality control checkpoints. Cameras scan for dents or sealing issues, scales verify weight accuracy, and inspectors pull random samples for manual testing. Any product that fails, even one standard, is removed immediately. By the end of the line, thousands of identical cans and perfectly shaped loins are packed into boxes for distribution. What began as a fast-moving predator in the open ocean is now a dependable food product ready for supermarkets, restaurants, and home kitchens across the United States. Every year, millions of tons move through international markets, supplying everything from premium sushi bars to everyday pantry staples across the United States. Canned tuna remains one of the most affordable proteins in American households, while high-grade fillets travel to restaurants where freshness and texture are critical. Yet behind this enormous trade lies a challenge shared by every fishing nation: how to protect tuna populations while meeting rising demand. Heavy harvesting, shifting ocean temperatures, and accidental bycatch have put pressure on several species, especially those with slow recovery rates. In response, many countries and industry groups have adopted new sustainability measures: catch limits, satellite monitoring, seasonal closures, and certifications that require full traceability from ocean to shelf. Some regions are also investing in tuna aquaculture, hoping to reduce reliance on wild stocks. Although still developing, these efforts reflect a broader understanding that long-term stability is essential not only for marine ecosystems, but for the millions of workers who depend on tuna for their livelihood. Looking back across the entire journey from fast-moving schools in the Pacific, to industrial vessels, to the cold chain at sea, to the precision of modern processing plants, and finally into global markets, tuna represents more than a single product. It is a complex system of technology, labor, and natural resources working together. The future of tuna will depend on how well this system maintains its balance, harvesting efficiently without exhausting the ocean, innovating without ignoring environmental limits, and feeding the world while protecting the species that make this industry possible. As the demand for seafood continues to grow, that balance will define the path forward for both tuna and the oceans that sustain it.